In this video, I will be explaining in more details the data flow from the microcontroller to the Jetson and from the Jetson to the microcontroller for the different configuration data that we want to send between the two. So in this project, there are multiple sensors like the IMU or the gyroscope or the mass sensor, which needs to have some type of data or calibration data that is saved on a non-volatile memory. So in our project, we decided to save these calibration data on the Jetson inside of a YAM file, so in the avionics config package. So now the question is, how do we send all of these parameters to the microcontroller so that it can reuse them and have and can then send the calibrated data back to the Jetson. To do this, we have a following sequence of operation. So when the sensor is created, if it needs a configuration, it will request a configuration by sending a configuration request on the CAN bus. The Jetson will then receive the configuration request and will in turn send back the configuration that it reads from this YAM file. Then the microcontroller will receive that configuration. It will set its parameters according to what it has received. So for example, an offset on the accelerometer or a transform matrix to correct the values that we read from the sensors. And after it has set its parameters, it will send back a response packet on the CAN bus. And the Jetson will receive that response packet and update the parameters accordingly. So why do we do so many back and forth? This is because this is a very modular way in the sense that we can either wait for a request from the microcontroller to receive a configuration. So this was the principle that I just explained. So microcontroller requests from the Jetson, Jetson responds with a configuration packet, and then the microcontroller sends back what it has configured. So this is the first way. But there is also a second way, which is to directly configure the microcontroller. So we could send a configuration packet to the microcontroller with the relevant data, like an offset, as I said, on some values. Then the microcontroller would send back a response, and the Jetson will receive that response and update this calibration parameters file according to what has been set on the microcontroller. So this is the basic flow of data, and I will explain in more details now how this all works. So let's take as an example the IMU, and in more specifically the accelerometer. So how do we configure the accelerometer? For this, we use multiple messages which are defined, or multiple packets which are defined in the broker library. So let's look first at the broker library. So if you go in Broco, then you go in include protocol and protocol23.h, you will have as usual a list of all of the different packets that we're using. And here are the three packets that we will be using for the configuration of the accelerometer. So this packet here, which has the rec as its first words here, is the packet that the microcontroller sends to the Jetson to request some kind of configuration. So we can set these values to false or true or based on whether or not we want to receive a certain configuration or not. So if we want to receive a certain offset or a certain bias, we could set this to true and then send it to the Jetson. If we don't want to get the transform, then we could set this field to false before sending the message to the Jetson. All right. Then the Jetson will send back an accelerometer config packet. So this is a type of packet that is sent from the Jetson to the microcontroller, and it will send back the information that we want. So the bias, for example, or transform matrix in this case. It will also send back two values here, which define whether or not we want to use this information, because it could send back, for example, a bunch of zeros here. If here we set it false because we didn't want to get the transform, then this here could send a bunch of zeros here, and so that we and and to be able, if we receive zeros here, we don't want to set it inside of our accelerometer, so we need to read this field here, and if it is equal to false, then we know that this is not the information that we want. So basically, if this request the transform, and if we set this to true, then normally this packet here that we get back from the JSON should also have this field equal to true, and the same can be said if it is false. Okay. The remote comment field here is just a way to discriminate between messages, between requests that are sent from the microcontroller or, or comments that are sent from the JSON. So let me clarify a bit about this part here. So let's say that we request repeatedly from the microcontroller. So we have a loop that requests multiple times the configuration until we receive it. What we want is that once we have received when we have received the packet or the configuration here, we don't want the following messages to be taken into account, because that doesn't make any sense, as if we request multiple times in a single run, then the first one or the fifth one will request the same configuration. So in this case, we can set, we know that the remote command here just indicates whether or not the first request was done from the microcontroller or from the JSON. So in the case where it is done from the microcontroller, we will set the remote command to false, which means that the command was not done remotely, it was done by the microcontroller. So this is one way to discriminate it. And if we try to configure the microcontroller from the JSON directly, so without having any request from the microcontroller, so let's say we are at runtime, like the rover is running somewhere, and we want to reconfigure the accelerometer, so we send a configuration packet here from the JSON without going through this request packet from the microcontroller, then we can set the remote command to true, and this will allow us to discriminate between these two packets. So we'll explain in more details about why we want to discriminate these two packets later in the video. Okay, so now let's get to this one. So once we have received the packet here from the JSON, so either after requesting it or if someone just sends it from the JSON, then the microcontroller here will return or will send back a packet with the current configuration that we have, and whether or not we should update the configuration file. So if we set these two fields to true, then when we receive this message on the JSON, it will update the corresponding fields in the configuration file. And this here is just a way to say if the configuration has been done successfully or not before we send back the packet to the JSON. Okay, now let's go through the code. So it might be a bit clearer if you look at the code. So if you go in source and AHRS thread, let's have a look at first at the init function. So this function here is first called when we initialize the thread, and we can see that after initializing all of the sensors, it will request some configuration data. So let's go first in this config accel function. So this one will just create a new, we already have a new packet here, which is a configuration from the a request from the microcontroller to the JSON. So first we need to define which fields we want to receive from the JSON. So if we want to receive a bias configuration and a transform configuration, then we need to set these two fields to true, and the JSON then should send back these values here. Okay, so this is just a way to choose which values we want to request from the JSON. Then, as usual, we just compute the ID and the CRC of our packet, and then we need to set the destination ID of our packet, which is the JSON, and then send it on the network. So this is how we request a configuration. Okay. Then on the JSON side, what happens is very similar to what I showed you here. So what we did here is we basically sent a request from the microcontroller on the two buses to the Jetson, and then the Jetson here receives the data or the packet on the Roku um, as a Roku message, and each packet here from on the two buses will be interpreted by a different node. So we will have one Roku-ROS interface node on the CAN 0, one Roku-ROS interface node on CAN 1, and they will each receive one packet because we have sent one packet on each bus. It then will go through the multiplexer as usual. So we will have two topics that are published from the packet here. So you can see here in the code, if you go in the calibration in the topic names params, the Axel config rec MCU topic is this. So it will actually publish on /can0 and /can1 of this topic here. Okay, so we'll have two topics. Then the avionics mux will choose on which topic is the reliable one, depending on the CAN0 node state and the CAN1 node state. So if you don't remember, these topics here are just topics that are a list of Boolean values here. And for each index, we say whether or not the node is available on the bus. Okay, so here, if you have 16 values and the fourth one is, or the fifth one in this case is true, then we know that the ID number 4, so this is 0, 1, 2, 3, 4. We know that ID number 4 is connected on CAN 0. Okay, so in this case, it would be this node here. And depending on the state of the node, we can choose whether or not we want to get the information from CAN 0 or from CAN 1. And this information then will be published on the final topic here, which is, in this case, this topic. So an Axel config microcontroller request. Okay, so it goes through the multiplexer as usual. So this is what we get from the microcontroller. And you can see this in the publisher. So this is a very, very similar concept as what I explained already in the publisher video when I was talking about the communication protocol. So as usual, we defined a handle for that packet. So this was the Axel config request packet sent from the microcontroller. Okay. So we just set the message ID and we set the request bias equal to the packet bias, the request transform equal to the bias transform. And then we will just publish here on the topic. Okay. So this message here is a custom message that was defined in the avionics interfaces as usual. And if you have a look at this, so Axel config request MCU. So you can see that it is exactly the same as what we defined in our Roku protocol. So it's exactly the same as this one, except we added, as usual, so this is not new, we added the ID from which the message comes from, okay? This is very similar to the other video that I already explained. So we just have to publish on this. And then what happens on this after publishing on this? So if we have a look at the avionics config here, so this is the avionics config package. Then we go in source and config manager. And here you will see what happens. So the message that we just published on the topic here, on this topic, this publisher here, has a subscriber in the configuration node. So the subscriber is defined here. I mean, this is the callback function to the subscriber. And let's have a look at how this works. So if you go into config manager.h, you will see here that we have defined a subscription to the Axel config request microcontroller. So this is the message here that was just published. And then if you go in the config manager.cbp, you can see which callback function we've associated it with. So the Axel config request microcontroller topic, this is just the message we've received. And we have the Axel config request callback function. So it will call this function. So after receiving the message from the microcontroller, it will publish on this. Then we'll have this callback function, which is called because we have a subscriber to that topic um, uh, in this node. And it will call this callback function here, which then publishes to another topic. So what this does here is it will publish to not the Axel config request MCU topic, but it will publish to a message of type Axel config request JSON topic. So we need to differentiate between requests from the microcontroller and requests from the JSON, which is why we've defined two types of messages, one which come from the microcontroller and one which comes from the JSON. Okay. So if you have a look at the JSON side of things, so if you look at the Roku interfaces message, and we have a look at the Axel config request JSON, we see here that it contains all of the information that we want to send to the microcontroller. So it is actually the packet that we will receive on the microcontroller. So this is actually this packet here that we receive. Okay, so you can see that it has exactly the same fields, have the bias, transform, remote command, set bias, set transform, and it also contains here the destination ID, which is the ID of the node we want to send the configuration data to. So it's very, very similar. So let's have a look at how this works. Okay, so if we open again the Broco manager, here the config manager, we'll see that it first sets the destination ID. Okay, so the message ID here is actually the ID that we receive. Okay, so if you remember, the Axel config request MCU here this is a ROS message, which was converted from a Roku message. It was this message here. And this message here has an ID because it's an identifiable packet. So it has an ID and a CRC. And then what we do is we simply get that ID and put it inside of the message that we want to send back to the microcontroller. So it's just like some kind of ping, okay? The microcontroller sends a message with its ID, and then the JSON knows which ID it is coming from and sends back the configuration to that ID. So this is why we get this ID here. Then we set the remote command equal to false. So this is because this is a request from the microcontroller. Okay, this is a subscription to the Axel config request MCU, and this is not a request from the JSON, you could say, because the microcontroller has requested this configuration. It's not the user who has sent this message from the JSON. Okay, so it's not a decision that was made from the JSON. So we set this to false. Then we set the set bias and set transform according to what is inside of that message. So if the microcontroller here has requested a bias, then we need to set the set bias equal to true, because then it means that when we receive that packet here, we know which field to use when we are configuring the accelerometer. Okay, so we just set these equal to what we receive here, and okay, and then we need to get the parameters from the YAM file. So to do this, you can just use the get param function. Okay, so this is a custom function that I written. You don't need to know too much about this, but it's using templates and other things of C++, and also the YAM file, the YAM CPP library. So it's not very easy to understand, but you don't really need to understand all of this code and how I am updating the YAM file and stuff. So you just need to know how to use this. Okay. So we just get the parameter here, and we want to get the accelerometer, the accel field. So to do that, we just look at the field. So we are using the accel, and we want to have the bias and transform field. So here we have accel, and we access the bias and transform fields. Okay, so then we just get these two as vector of doubles, and then we can just fill the fields of our messages. So our message has a bias, and we just um, set this field equals to this field, which we just got from the calibration file. And then we send it back to the microcontroller. Well, this is not on the microcontroller yet, but we send it back on the topic, which is on the topic accel config rec pub. So this accel config rec pub is of a certain type, which you can see here. So it's of type accel config request Jetson, okay? Because this is now a request from the Jetson. Okay, so as a summary, because it was quite long, the microcontroller sends accel config request packet, which is then received by all of this network here. And on the Jetson, the Jetson receives it and publishes it on a topic which is of type accel config request MCU. Okay, we have a subscriber on that topic, which then is used to publish back on the accel config rec pub topic, and this topic here is of type accel config request Jetson. Okay, so this is the subscriber, and we publish back on an accel config request Jetson. So it was quite complex, but this is how the whole process works for now. Okay, so now how do we send it back to the microcontroller? So what we did here by publishing on this topic here is that we just go the other way around. So we just publish on the topic here. It will go through the avionics mux. Then it will be unmultiplexed through two topics. Okay, it will choose on which topic to publish. And then it will go through this interface depending on the state of the node. And it will publish back a message to the Jetson. Okay, so it just does the road, but in the other way. Okay, so you can have a look maybe at the multiplexer if you want. So let's have a look at the multiplexer. You can see here in the MUX publisher in this case, or maybe the MUX subscriber, that we have an is it here? Yeah, you have here the accel config request Jetson. Okay, so this is the packet that we just sent back. Okay, so it is also in the multiplexer in order to publish on the correct bus. Okay, so it then goes through the multiplexer as usual. So this is any message will go through the multiplexer in our network. Okay, and then it will go back to the Broco subscriber here. So if I type accel config, you can see here that we have a subscriber to the accel config request. So this is what we just sent through the network. And this accel config request has a callback function, which is here the accel config request callback. Okay, and this accel request config callback will create my message and send it on the CAN bus. So it will just get the data from the accel config request Jetson. Okay, and this is as usual. So if you watch the video about the communication protocol, you should already be familiar with this part. And then it will just set all of the fields according to what it has received here, and then set the bias and transform, and send the data to the CAN bus. So what we've done here essentially is microcontroller requests a configuration. It goes through all of this network, It then publishes on a certain topic. The Jetson subscribes to that topic, publishes on another topic. Okay, then we have another thing that subscribes to this topic and converts it to a Roku packet. It sends it back to the microcontroller. So we just did one go on from this side and one way from this side to this side. Okay, so this is just a round trip for now. Then on the microcontroller, we just received here the Axel config request packet. Okay, so this is what we just received. So if you look through the handle, this is the message that we will get. So Axel config request packet, which calls this callback function here, handle set Axel config. And this is a fairly complex function. So what it will do is it will first check if the packet is reliable. It will then create already a response packet because we want then to send back the data to the Jetson. So in order to update the calibration parameters on the Jetson, so we want to update these calibration parameters files depending on what configuration we have set on the microcontroller. Okay, so it will first create this Axel config response packet, which will later be sent back to the Jetson. So it sets here the parameters. Then it will first set the response packet field to 0. So this is to make sure that every field is set, because we've encountered issues with memory if we didn't set all of the fields at least once. Okay. Then we check if we have something, if the thread is existing first, and we check if the packet is from a remote command. So this is true only if the Jetson has requested it first. It's false if the request was coming from the microcontroller. Okay. So you can see here that this will be executed only if there are two conditions. So this part here will be executed every time if the remote command is equal to true. So this means that it will always accept requests from the Jetson. If we directly send a configuration from the Jetson without having a request from the microcontroller, then we will always go inside of this code here. And the other condition is we don't want our accelerometer to already be configured. Okay. So if the accelerometer was already configured, so if we already sent something and we already received the configuration, then we don't want to reconfigure it. Okay, so this is another condition. So after this, what it does is it simply checks for which parameters it should set inside of the accelerometer. So we can check for the set bias and set transform fields. So if you remember, these were set according to what we receive from the microcontroller. So if the microcontroller was requesting was requesting a bias, then we would just set this field here of the message equal to this, so that we know which part of the configuration we want and which part we don't want. So it just checks for these fields here, and then it will set the transform, or it will set the bias for the IMU. So these are really functions that just set the parameters according to what we give it. Okay. After this, it will also compute, set the parameters of the bias here, which is for the response packet that we want to send back to the Jetson. Okay, so we just fill this part of the response packet. If everything is fine, then we will set the success to true. If it's not, then we'll set it to false. Okay, so there are many occasions where it could be false here. And finally, we just send our packet as usual. So we first make it identifiable by setting the ID. Then we set the CRC, set the destination ID, and send it back on the network. So in order to not have multiple responses for a single packet, what we can do is to just send the response on the bus from which it was received. Okay, so the sender ID here will be equal to either 1 or 2, depending on if we received it on the CAN bus 1 or CAN bus 2 of the microcontroller. So in order to really optimize what we send, we can simply send it on the same bus on which we received the configuration. So here we will just send back the response packet. Okay, so we send back the response packet, and this response packet here will be received back by our Roku interface. So it will go again through all of this loop here. It will be multiplexed again as usual, just like any other data, and then it will publish on a certain topic, which in this case is /el/axel_config_response, if I remember correctly. So if you look in the topic names params here, we have here what we talked about before, and here we have the response, which is coming from the microcontroller. Okay, so it will go through all of the multiplexing thing again as usual, so I won't go through this again. And what you have to know is that inside of the avionics config package, we should have a subscriber to that topic here, to that response topic. And this subscriber here will be used to update the calibration parameters. So here we have the Axel config response callback as I've just described. So this callback here is the callback of a subscriber to the Axel config response packet. Okay, so Axel config topic here is so this is the topic to which we are subscribing. It's of type Axel config response, and it will call the Axel config response callback. And here you can see that when we receive the response from the microcontroller, we will just save the data in the YAM file, so inside of that calibration file here, and we only save it if, of course, the set bias is true or the set transform is true. Okay, so it was quite long, I know, and it might seem overcomplicated, but this is a very, very robust way to send data to the Jetson or to the microcontroller, send configuration data, and be sure that everything is up to date on both sides, so on the microcontroller and on the Jetson. Okay, so I will go through it one more time, really to drill this into your mind, I guess, and to be sure that everything is understood. So I will just go through it very quickly in a very concise manner. Okay, so let's start from scratch. So the microcontroller here requests a configuration to the Jetson. To do this, it sends a certain packet, which is of type Axel config request packet in this case, and this packet will contain different fields which say which part of the configuration it needs. Okay, this packet here will go through the CAN bus. It is then interpreted by these two nodes here. It then publishes this packet on ROS topics, on two different ROS topics. The avionic mux chooses which topic to trust and publishes it on a final topic. Then we have the avionics config here, which subscribes to that final topic. Okay, and from that final topic, it then sends back the actual configuration. Okay, so here it would be in the Axel config callback here. So this is what it receives, and then what it does is it reads the data from the YAM file, the calibration file, and then sends back the data to another topic. Okay, so this is a config topic from the Jetson, okay, an Axel config request Jetson. So right now we are doing this, and then we have to come back. So it publishes on another topic, which is a request Jetson topic. This topic here goes through the multiplexer, then goes through either this way or this way, depending on the states of the nodes. It then is converted to a ROCO packet and is sent through the appropriate bus of the CAN network. Okay, and then on the microcontroller, we receive that configuration data, which is of type Axel config packet in this case. We get this data here, which calls the callback function inside of our AHRS thread here. So it calls back this callback function here, which sets the actual configuration inside of the accelerometer. And the callback function prepares a response packet. Okay, so it fills a response packet here, which is of type Axel config response packet. And this response packet is sent back to the network. Once again, goes through the multiplexer, publishes on 2 topics, and is published here on the final topic as usual. And this response packet here is also subscribed to in the config manager here as an Axel config response callback, and is used to update the YAM file. Okay, so in that way, we are sure that if we are sending a configuration, we are sure that the YAM file is always kept to date here. So the calibration params will always be kept to date with the microcontroller, and that it will not be like wrongly modified. So let's say that if we send a calibration to the microcontroller, if there is for some reason a failure, for example, this cable here is not connected, then it will not send any response. So we don't do anything on the YAM file. And now let's say that we send a message here, and for some reason there is an issue because the IMU is not connected. Then it will send back a response and say that it hasn't successfully set the configuration. This response will go through all of this, and the final node here on the callback function of the response here will see that the success was false, and then it will not set the parameter inside of the YAM file. So this is the whole like structure of how the data goes through for the configuration. I know that this was a pretty long video and it might not seem very clear right now. So I have a small video also showing an example, a practical example of how all of this works. So stay tuned and yeah. So if you have any questions, I will be happy to give some more details about how this works. In this video, I'll be showing you a practical example of how the configuration works and how we actually see it inside of the terminal. So I've recorded 2 videos, one on the Jetson and the one on my computer, which is connected on the on the PCB through the serial port of the PCB, so through the UART to USB connector. And now let's play the video at once so we can see what's happening. Okay. So here I've just started the code on the left. So this is the code that is running the avionics code. And what you can see, so here I've unplugged the IMU. And what you can see here is I've just reset the IMU on this side. And you can see that on the left side, I've received a configuration request. So here on the right side, this is on the microcontroller. It requests a configuration for the accelerometer, gyroscope, and magnetometer. So this is what I was talking about in the AHRS thread. So we have the request configuration. Okay. So it was the request config. It will send a message to the microcontroller, which receives it. And then here it will say that it has received the configuration. So it says here that it has received, well, it doesn't say it actually, but it has received it, and then it will send the configuration to the microcontroller. So it will send an Axel config, gyro config, and mag config. So this is in the schematic that I was showing you, we just did one from this part to the Jetson, and then the Jetson is sending back the data. Then on the microcontroller, we will set the data that we've just received from the Jetson. So here you can see the different parameters. So we have this configuration matrix here and these offsets for the magnetometer, for example. Here we have the bias and the transform matrix for the accelerometer. And so this is what we received from the Jetson. And then this microcontroller sends back a response packet to the Jetson. And we can see here that it has successfully received that response packet, and it is saving the data inside of the YAM file that I was talking about before. Okay. So now we can even check the YAM file. So this is what I do here. I just open the code. I go into calibration params, and you can see here, for example, on the Axel and magnetometer, that the parameters are exactly the same. So for the soft iron, for example, we have 0.969, and this is what we sent back from the microcontroller. And here we also have 1.402, which is what we are sending here from the microcontroller. So the back and forth exchange between the Jetson and the microcontroller is working very well. And this is just a proof that the code is working as expected.